We are going to have a look at vectors and scalars. Now, what is a vector? A vector is a physical quantity that has both magnitude and direction. Here. On the scalar quantity has magnitude only. Now, what do you mean when we talk about the physical quantity? Physical is something tangible. Say 5 kg, 3 meters, 4 hours. Tangible, real quantity there. Something physical is real. Something tangible. And quantity is just an amount. Magnitude is size. So an amount that has both magnitude and direction is called a vector. Well, an amount that has, now we want to have a look at the examples of vectors and scalars. Now, speed is a scalar quantity, while velocity is a vector. Now, we have velocity. We have force. We have the weight. We have acceleration. We have here speed. We have distance. We have here volume. We have here displacement. Now, as we continue with the physics, we will continue, we'll keep on adding on this list, on this table here, like electric field strength, which is a vector. It's also important to indicate the unit that velocity is measured in meters per second, force is measured in Newton, the weight is also measured in Newton, acceleration in meters per second squared, displacement in meters or centimeters, speed meters per second or kilometer per hour, distance in meters, volume centimeter cubed or decimeter cubed. We also have, don't forget the mass as well, which is given in grams. Right. The question is, how do you represent a vector? We use a line. we use a line to represent a vector. That will be a vector. Now, because by definition, a vector should have magnitude and direction, therefore, the length of the line will represent the magnitude of a vector, but we use an arrow to indicate the direction of that vector. Now, you also have a cardinal point, that is your north, the south, the east, and the west. Now, or you also have the degrees. 0 degrees is here. Those who are doing mathematics, they know that their 0 is somewhere on the east there. In physics, our 0 is up there on the north. Now, this can be the same as 5 meters east as a displacement. This becomes a displacement. A displacement vector can be represented in that way. Now, let's have a look at what happens when I have 2 or more vectors parallel to each other. Now, I can have 4 vectors like I have there. Let's say this vector A, vector B, vector C, and vector D. Now, if here I have 3 Newton force east, and here I have 2 Newton force east, and here I have 5 Newton east, and here I have 8 Newton west. Now, if I have vector A plus vector B, vector A plus vector B will be 3 Newton east plus 2 Newton east, and that gives you 5 Newton east. And this vector here is called the resultant vector. And a resultant vector is a single vector that produces the same effect as the combination of 2 or more vectors acting together. The same effect as a combination of 2 or more vectors acting together, or acting at a point. That is the definition of a resultant vector. Let's go to C and D there. C and D will give us 3 Newton. C and D will give us 3 Newton because we have 5 Newton there and we have 8 Newton there. Now, we say vector C plus vector D will equal to 5 Newton minus 8 Newton, because this one goes east and this one goes west, negative 3 Newton. Note, the negative sign in vectors shows direction. So this sign here is not mathematical, it's a physical one. It shows that this vector goes in the opposite direction. This vector goes in the opposite direction. That is R. Now, if you have linear vectors in the linear vectors there, vectors in a straight line, that's how you get the resultant. Now let's see when they are perpendicular. If you have vector A and vector B, vector A and vector B, let's say vector A is 4 meters, vector B represents 3 meters. Now, someone moves from point A, goes to point B, and goes to point C there. Now, if somebody moves from A, straight to C there, we will have AC as the resultant vector, because by definition, a resultant vector is a single vector that produces the same effect as the combination of two vectors. Now you move from A to B, from B to C, just like you move from A to C. Therefore, this is the resultant vector. But because one vector A was 4 meters at 270 degrees, and this C moved east, we say these are perpendicular to each other. We can use Pythagoras in that R squared will equal to A squared plus vector B squared in units. This is 4 meters squared plus 3 meters squared. And that will give you 16 meters squared plus 9 meters squared. And this will give you 25 meters squared. Therefore, R will equal to the square root of 25 meters squared, which is 5 meters. But we agree that this is a vector, and by its definition, by its very nature, a vector must have magnitude and direction. Now, we'll have an angle theta here, and you know that that angle theta can be given is opposite to this 3 meters here, but is next to, is adjacent to 4 meters there, which is A. Therefore, you can say the tangent of theta is opposite over, mathematically opposite over adjacent. And then the opposite side is 3 meters. The adjacent side is 4 meters. And then that will give you 0.75. That is the tangent of theta. Therefore, theta will give you arctan of 75. That's going to be tangent 0.75. And that will give you maybe 53 degrees or something. That will give you now, that will give you 36.86. degrees. Now you can give the angle at 36.86 degrees. Now you have your south and then your east goes that way, so 38 east of south. Now, because these vectors are perpendicular to each other, we have just made use of the theorem of Pythagoras to solve that. Now let's look at other vectors. You can have a vector here, then a vector there. Two vectors acting at the point. Let's say here you have 25 to 2. Let's say you have 2 newtons. And then here you have 45 Newton. And here you have 30 degrees. One vector, one dog is pulling that way. The other dog is pulling in that direction. Now, the trick here is for you to know that you can take a vector, and put it anywhere as long as you maintain the magnitude and the direction. So we can take this 45 and put it there. Now, if they are in the same direction, we mathematically expect them to be parallel. And if they are parallel, this angle here and this 30 degrees form co-interior angles, then we expect that to be 150 degrees. So basically, you can take your ruler. If you are given a scale, you take your protractor, you measure here 150 degrees, then you'll have 45 Newton there. If you are using a scale, you have 52 Newton here. Then from that vertex, or from the common point, we will have a vector going there, and that vector will be our R. That vector will be our R. So 52 degrees plus 45 at that angle will give you R. And if you use a scale, you have to choose a suitable one, and then you can measure those centimeters there and convert them into newtons. You can say 10 Newton is equal to 1 centimeter. But if we use calculations and not scale drawing, you will appreciate that the cosine rule will help you here. That R squared will equal to 52 squared plus 45 squared. We use the cosine rule of mathematics. Minus twice 45, 52, the cos of 30 degrees. Punch that in your calculator, and you get that, and you say R will equal to your answer there. So that will be R. Now, if you look at this diagram here, you'll appreciate that I could as well have taken 52 here. Now the whole thing forms a parallelogram. And then this is called a parallelogram method of solving vectors that are acting at the point. We will have as well a number of vectors. If you have a vector 1 going this way, 2 going that way, 3 going this way, 4 going that way, 5 going that way, 6 going this way, 7 going this way, we will have this vector here. This vector will be our R. That will be the resultant vector. By its definition, a resultant vector is a single vector that produces the same effect as the combination of other vectors. I can have vector A, B, C, D, E, F, and G. This will be my resultant vector. Note, for you to have R, it must be head to tail, 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 and here is head to head for resultant. Now have a look at this one here. If I have a vector there and another vector there, and another vector here, and we look at the directions of those vectors. The first vector was going this way. The second one came here, was facing that way. And the other one was coming this way. Now, the resultant here, R, is 0. Why? Because there's no head to head here. It's head to tail, head to tail, head to tail. No head to head. Therefore, R is 0. If I had here 3 Newton, and I had here 7 Newton, and I have 8 Newton, R will be 0 Newton. And by Newton's first law, we will say that the forces are balanced. That's why you have 0 Newton. Now, let's draw once more. Let's draw once more. A vector going that way. And another one coming this way. Now, a boy moved from position A to position B, and from position B to position C. And he moves here 8 kilometers. And then he moves here 6 kilometers. Now, you can say that from C to A is a resultant vector. C to A constitutes a resultant vector. And if this is perpendicular, you can use Pythagoras. Let's say the boy runs from point A to point B, and he takes 6 seconds, and he moves from B to C and takes 4.5 seconds. Now, we are going to have a look at the distance that the boy has moved. And then we are going to have a look at the displacement that the boy has experienced. Then we are going to have a look at his speed. Once more, have a look at his velocity. Now the distance, if we solve for 1, distance that the boy shall have moved is 8 plus 6, which is equal to 14 kilometers. And displacement, displacement is the shortest distance between 2 points, definition of a line. So from A to C, we can use Pythagoras there. We'll have AC, the square root of 6 squared plus 8 squared, 36 plus 64, then the root of 100, which is equal to 10. Then displacement will be 10 meters. You need to give the direction there because displacement is a vector. It has magnitude and direction at an angle there. You can use the tangent opposite over adjacent. If you want to calculate the speed, is the rate of change of distance. That is the distance, rate of change of distance, divided by time, that's the rate. The distance that the boy has moved from A to C is 14K. The time he has taken 10.5. So we need to convert that into meters. Divide by, this boy should be on drugs, running too fast. Yeah. Then divide by 10.5. This is equal to 1 meters per second. And his velocity is a vector, rate of change of displacement displacement is 10 meters at the angle of theta for direction. And this is kilometers. Divide by seconds. That is 10,000 meters. Divided by, this is 952. This is 952.38 meters per second. There you are. Now, please note that displacement is a vector, velocity is a vector, and distance is a scalar quantity, no direction. Speed is also a scalar quantity, no direction. For a vector, that theta will give us a direction. And then we forgot theta here for a direction.